Imagine, just picture this. You're on a spaceship, right? And you're leaving Earth behind.
Okay.
And as you journey outward, the sun shrinks, to a pinprick.
Right.
And ahead of you loom these two giants.
Yeah.
Jupiter and Saturn, the gas giants.
Yeah.
They've fascinated us humans for millennia.
They have.
And today we're taking a deep dive into the missions that dared to explore them.
I love it.
Welcome to Cosmos and a Pod of the Space and Astronomy series.
Yes.
Please like, comment, share, and subscribe.
Absolutely.
Okay, so let's unpack this, right?
Right.
We've got Jupiter the big boss.
He is.
And Saturn the ring king.
That's right.
But before we launch into the missions themselves,
Yeah.
what makes these gas giants so different from, say, our rocky neighbor Mars?
Well, what's really captivating about them is their sheer scale. I mean, Jupiter's mass is greater than all the other planets combined.
Really?
Think about that for a second. It's a giant among giants.
That's incredible.
And its atmosphere is a constantly shifting canvas of color and storms. You've probably heard of the Great Red Spot, right?
Yeah, the superstorm that's been raging for centuries.
Yeah.
Is it really bigger than Earth?
Oh, it's much bigger. It's like a swirling hurricane that dwarfs our entire planet.
Oh, wow.
And then you have Saturn with its iconic rings.
Yeah.
These aren't solid, by the way.
Right.
They're made up of countless icy particles ranging in size from dust grains to small mountains.
Wow. Okay, so I'm starting to get a sense of just how huge and complex these planets are.
Yeah.
But there must be a whole other challenge, right?
Exactly. It's not like hopping over to Mars.
Yes.
Years to reach Jupiter.
Wow.
Almost a decade to Saturn.
Wait.
These missions are true feats of engineering and endurance.
That's amazing. So who were the first brave souls to attempt this cosmic journey?
It all began back in the late 1960s.
Okay.
NASA, ambitious as ever, decided to look beyond the inner solar system.
Right.
That's how the Pioneer missions were born.
Okay.
Pioneer 10 and 11, humanity's first emissaries to venture past the asteroid belt.
The asteroid belt, wasn't that a pretty risky move back then?
It was. No one really knew what dangers lurked within that belt of space debris.
Yeah.
But Pioneer 10, launched in 1972, braved it.
Wow.
And became the first spacecraft to reach Jupiter.
Really?
It sent back over 500 images,
Wow.
giving us our first real look at Jupiter's swirling clouds and its powerful magnetic field.
It must have been like seeing an alien world for the first time.
Absolutely. Then came Pioneer 11, launching in 1973.
Okay.
It followed its sibling to Jupiter,
Right.
but then did something really clever.
What's that?
It used Jupiter's gravity like a slingshot to propel itself onwards to Saturn.
Wait, you can do that, use a planet's gravity to speed up a spacecraft?
It's called a gravity assist. It's like stealing a bit of the planet's momentum to give your spacecraft a boost.
Oh, wow.
It's a pretty common technique in space travel, especially for long-distance missions.
Yeah.
It allowed Pioneer 11 to become the first probe to reach Saturn, sending back the first close-up images of its rings in 1979.
That's so ingenious.
Yeah.
It makes you wonder what else we can use gravity for in space.
Right.
But these pioneers, they were just the beginning, right?
Right. They proved outer solar system travel was possible.
Okay.
But what came next was even more ambitious, the Voyager missions.
Ah, the Voyager, the rock stars of space probes. Didn't they have a pretty unique opportunity?
They did. It was like the universe was giving us a cosmic gift.
Okay.
In the late 70s, a rare planetary alignment occurred,
Right.
meaning all four gas giants,
Wow.
Jupiter, Saturn, Uranus, and Neptune,
Yeah.
could be visited in a single mission.
Really?
That's how Voyager 1 and 2 were born.
Wow. So Voyager 1, where did it head first?
It arrived at Jupiter in 1979,
Okay.
capturing those iconic images of its swirling atmosphere and its Great Red Spot.
Yeah.
But it didn't stop there.
No.
It also beamed back detailed images of Jupiter's moons,
Okay.
including Europa, a moon with an icy surface,
Right.
and a potentially hidden ocean beneath.
Europa, that's the one that scientists are really excited about, right? Because of the possibility of life.
Exactly. Voyager 1 provided our first hints that Europa might have a vast global ocean hidden under its ice.
Yeah.
Sparking the search for extraterrestrial life in our own solar system.
Wow.
Then Voyager 1 continued on to Saturn,
Okay.
becoming the first probe to capture detailed images of the planet's stunning rings and revealing the hazy atmosphere of its largest moon, Titan.
Titan? I've heard it's like an early Earth in some ways. Is that true?
It's a fascinating place, that's for sure. Voyager 1 discovered that Titan has a dense atmosphere,
Okay.
thicker than Earth's,
Wow.
made up mostly of nitrogen with hints of methane and other organic molecules.
Interesting.
It suggested Titan might have weather patterns and surface liquids,
Okay.
but not water methane.
Methane lakes.
Yeah.
That's wild. Okay, so Voyager 1 visited Jupiter and Saturn.
Right.
What about Voyager 2? Did it follow the same path?
Voyager 2 took the scenic route, visiting all 4 gas giants.
Wow.
It's actually the only spacecraft to have achieved this remarkable feat.
That's amazing.
It flew past Jupiter and Saturn, capturing data and images, then continued on to Uranus and Neptune,
Wow.
giving us our first close-up glimpses of these distant ice giants. It was like a grand tour of the outer solar system.
It's amazing to think that these little probes launched in the 70s are still out there traveling through interstellar space.
No.
But before we get ahead of ourselves,
Okay.
let's go back to Jupiter and Saturn.
Okay.
The Voyagers were flybys, right? Just quick glances.
Yeah.
But we wanted to learn more.
Right.
To really delve into the secrets of these giants.
Of course. And that's where our next deep dive takes us.
Okay.
From flybys to orbiters' missions designed to spend years studying Jupiter and Saturn up close.
Awesome.
Yeah. Yeah, the Voyagers gave us those incredible snapshots.
They did.
But to truly unravel the mysteries of Jupiter and Saturn,
Yeah.
we needed missions that could stick around, orbit these planets for years
Right.
and really dig deep.
Okay, so that's where the orbiters come in, right?
Precise.
Missions like Galileo, which focused on Jupiter.
Exactly, launched in 1989. Galileo wasn't just a quick visitor.
Right.
It was designed to be a long-term resident in the Jovian system.
I see.
It arrived at Jupiter in 1995 after a 6-year journey.
Wow.
And what followed was a scientific bonanza.
Okay, so Galileo's at Jupiter. Where do you even begin when you have a whole giant planet and its system of moons to study?
Well, Galileo did something incredibly daring right off the bat.
Okay.
It released a probe that plunged straight into Jupiter's atmosphere.
And into that swirling chaos of storms and intense pressure that's brave. What did the probe find?
It survived for about an hour, sending back data as it descended.
Wow.
Imagine enduring winds of over 600 kilometers per hour.
Oh my gosh.
And temperatures hot enough to melt iron.
Wow.
This little probe gave us our first taste of what it's like inside Jupiter's atmosphere.
That's some extreme weather reporting, but Galileo's main focus was on Jupiter's moons, wasn't it?
It was.
Especially Europa, with its tantalizing hints of a hidden ocean.
Europa became a star of the show. Galileo made multiple flybys of this icy moon, mapping its surface and measuring its magnetic field.
Right.
And the data was compelling.
What did it show?
It strongly suggested a vast, salty ocean beneath Europa's icy shell, potentially even larger than all of Earth's oceans combined.
So we went from hints of an ocean to strong evidence of a global ocean that must have been a game changer for scientists looking for life beyond Earth.
It was a paradigm shift. Suddenly, here is a place in our own solar system that might have the conditions necessary for life as we know it.
Wow.
It made Europa a top priority for future exploration.
But Galileo didn't just study Europa, did it? What about those other Jovian moons, the ones Voyager gave us glimpses of?
Galileo gave us a front row seat to the volcanic fury of Io,
Okay.
the most geologically active body in the solar system.
Wow.
Imagine a moon covered in volcanoes, spewing lava plumes hundreds of kilometers high.
That's incredible.
Galileo witnessed these eruptions up close,
Wow.
revealing just how dynamic and fiery Io truly is.
Volcanoes on Io, a possible ocean on Europa-Jupiter's system, is turning out to be pretty incredible.
And we can't forget about Ganymede.
Right.
The largest moon in our solar system, Galileo discovered that Ganymede has its own magnetic field,
Really?
something quite unusual for a moon.
Yeah.
It also found evidence of a possible subsurface ocean on Ganymede, adding yet another potential habitat to the list.
So many moons, so many potential secrets. Galileo really opened our eyes to the wonders of the Jovian system.
It did.
But what about Saturn? Did it get its own dedicated orbiter?
It did, and it was a mission for the ages, Cassini-Huygens.
Okay.
A joint effort between NASA, the European Space Agency, and the Italian Space Agency.
That's a lot of collaboration.
It launched in 1997
Okay.
and arrived at Saturn in 2004 after a 7-year journey.
Cassini-Huygens, that name rings a bell. Wasn't it a 2-for-1 mission?
You got it. Cassini was the orbiter designed to study Saturn itself, its rings and its moons.
Right.
Huygens was a lander.
Oh.
Specifically designed to touch down on the surface of Titan, Saturn's largest and most mysterious moon.
Okay, let's start with Cassini. What did it reveal about Saturn?
Cassini spent 13 years orbiting Saturn, sending back a treasure trove of data and images.
Wow.
It gave us an unprecedented view of Saturn's rings, revealing their intricate structure, their complex dynamics, and even the presence of tiny moonlets embedded within them.
Moonlets within the rings. It's like a miniature solar system within Saturn's rings.
Exactly. Cassini also witnessed massive storms raging in Saturn's atmosphere,
Wow.
including that bizarre hexagonal storm that swirls around the planet's north pole. It's a storm bigger than Earth with 6 perfectly straight sides.
That's wild.
Scientists are still trying to figure out how such a geometrically perfect storm can form.
Saturn's weather is definitely weird and wild, but let's talk about Titan. That's the moon that Voyager hinted might have methane lakes and rivers. Did Huygens confirm this?
It did. In 2005, Huygens descended through Titan's hazy atmosphere, revealing a landscape unlike anything we'd ever seen. It landed on a dry riverbed strewn with smooth, rounded pebbles, evidence that liquid methane had flowed there in the past.
Wow.
Cassini from orbit later confirmed the presence of vast methane lakes and seas on Titan's surface.
So it's like Earth, but with methane instead of water. It's just mind-blowing. What does a methane lake even look like?
The images Cassini sent back showed dark, smooth surfaces reflecting the hazy sunlight filtering through Titan's atmosphere.
I see.
It's a cold, alien landscape.
Yeah.
But those lakes and seas are real.
Wow.
Filled with liquid methane fed by methane rain and flowing through methane rivers.
It's like an alternate reality version of Earth's water cycle.
Yeah.
Did Cassini discover anything else about Titan?
It found evidence of vast underground reservoirs of liquid water,
Really?
suggesting that Titan might have 2 potential environments for life, a methane-based one on the surface and a water-based one deep underground. It's a moon of incredible diversity and potential.
Titan is definitely moving up on my list of places to visit in the solar system, even if it is a bit chilly. Did Cassini explore any of Saturn's other moons?
Oh, definitely. It made some amazing discoveries about Enceladus,
Okay.
a small icy moon that turned out to be much more active than anyone expected.
Okay, how so?
In 2005, Cassini observed plumes of water vapor erupting from Enceladus's south polar region,
Okay.
like geysers shooting into space.
The geysers on an icy moon? That doesn't sound right.
It was a huge surprise. Further observations revealed that those plumes were coming from a vast global ocean hidden beneath Enceladus's icy shell.
Really?
And analysis of the plumes showed they contain organic molecules, the building blocks of life.
Another ocean world, and this one is spewing its contents into space. It seems like every time we look closer at these gas giants and their moons, we find more and more evidence of potential habitability.
It's a testament to the incredible diversity and complexity of our solar system.
It is.
And the discoveries made by Galileo and Cassini have only fueled our desire to explore these worlds further,
Yeah.
to see what other secrets they might hold.
Well, these orbiters have certainly lived up to their names, revealing the hidden depths of Jupiter and Saturn. But as we know, their missions eventually came to an end.
They did, but their legacies live on,
Right.
paving the way for even more ambitious missions to explore these gas giants and their intriguing moons. And that's where our next deep dive takes us,
Okay.
to the future of gas giant exploration.
Okay, so we've journeyed from flybys to orbiters,
Yeah,
peeling back the layers of Jupiter and Saturn.
that's right.
But the story doesn't end there, does it?
It doesn't.
What's next in our quest to understand these giants?
Well, the thirst for knowledge never really ends.
Right.
While Galileo and Cassini completed their missions,
Yeah.
they sparked a whole new wave of exploration.
Okay.
Right now, there's a spacecraft orbiting Jupiter,
Really?
carrying on the legacy of discovery.
You're talking about Juno, right?
Yes.
The mission that's been beaming back those incredible images of Jupiter's swirling clouds.
That's when Juno arrived at Jupiter in 2016. And its mission is to peer deep beneath those colorful cloud tops
Right.
to understand what makes Jupiter tick. It's like taking an X-ray of the planet.
So it's not just about pretty pictures, though. Those are definitely bonus.
Yeah.
What's Juno looking for beneath the surface?
Juno is probing Jupiter's deep atmosphere,
Okay.
mapping its magnetic and gravity fields,
Right.
and trying to determine the structure of its core.
Oh, wow.
We want to know, for example, whether Jupiter has a solid core,
Right.
or if it's more of a fuzzy fluid center.
It seems like such a basic question. Does a giant planet have a solid core?
Right.
But I guess those are the fundamental mysteries we're still trying to solve.
Exactly. And Juno is giving us clues.
What kind of clues?
It's already revealed that Jupiter's magnetic field is far more complex and intense than we ever imagined.
Wow.
And its atmospheric dynamics are full of surprises. It's challenging our assumptions about how gas giants work.
So Juno's still busy up there gathering data. What about the future? Are there any missions in the pipeline that are going to blow our minds?
Oh, there are some exciting missions on the Horizon missions that are going to take us back to those intriguing moons that Galileo and Cassini revealed to us.
Yep.
Remember Europa with its potential ocean?
Of course, who could forget Europa? Is there a mission going there soon?
There are actually 2 missions in the works that will target Europa.
2? Wow.
One is the European Space Agency's JUICE mission,
Okay.
the Jupiter Icy Moons Explorer.
That name says it all. So JUICE is going to explore Europa and other icy moons?
Yes, it's scheduled to arrive at Jupiter in 2031.
Wow.
And it will focus on 3 of Jupiter's largest moons,
Okay.
Europa, Ganymede, and Callisto.
Wow.
All 3 are thought to have subsurface oceans,
Okay.
and JUICE will try to determine whether those oceans could harbor life.
3 ocean worlds around one planet, it seems like. The more we explore, the more potential habitats we find.
It's a fascinating trend, isn't it?
It is.
And while JUICE is on its way, NASA is developing its own missions specifically dedicated to Europa.
Okay.
The Europa Clipper.
Europa Clipper, that one's been generating a lot of buzz. What makes it so special?
Europa Clipper is designed to be a Europa expert.
Okay.
It's scheduled to launch in 2024.
Okay.
And will spend several years making close flybys of Europa,
Right.
mapping its icy surface, analyzing the plumes of water vapor that erupt from its south polar region, and searching for signs of that hidden ocean.
It's like Europa's getting its own paparazzi snapping close-ups from every angle.
In a way,
I got
yes,
it.
we want to gather as much data as possible
Yeah.
to determine whether Europa's ocean is truly habitable.
Right.
Is it salty? Does it have the right chemical ingredients?
All right.
Are there hydrothermal vents on the ocean floor that could provide energy for life?
Those are the big questions, aren't they? And Europa Clipper might just give us the answers.
It might.
But while Jupiter and its moons are getting a lot of attention, what about Saturn? Any future missions planned for the ringed planet?
There is one mission that's going to take us back to Titan,
Oh.
the moon with methane lakes and a possible underground water ocean.
Right.
It's called Dragonfly, and it's truly unique.
I'm intrigued what's so special about Dragonfly.
It's not your typical lander or orbiter. Dragonfly is going to be a drone.
A drone.
A flying robot that will explore Titan's surface from the air.
A drone on Titan. Seriously, that sounds like something straight out of science fiction.
It does, but it's happening.
Why?
Dragonfly is designed to take advantage of Titan's dense atmosphere and low gravity,
Right.
allowing it to fly long distances and take samples from different locations.
Wow.
It will be our eyes and ears on this incredibly intriguing moon.
It's amazing to think that we're at a point where we can send drones to explore alien worlds. When will Dragonfly take flight?
It's scheduled to launch in 2027
Okay.
and will arrive at Titan in the mid-2030s.
So we have a lot to look forward to in the coming decades.
We do.
From Jupiter's stormy depths to the methane lakes of Titan, the future of gas giant exploration is full of exciting possibilities. It seems like we're on the verge of a golden age of discovery.
I couldn't agree more. With each mission, we're getting closer to answering some of humanity's most profound questions. Are we alone in the universe? What are the limits of life as we know it? These gas giants and their moons hold the clues, and we're just beginning to unravel their secrets.
It's a journey that's both humbling and inspiring. Well, that's a wrap on our deep dive into the missions that have explored Jupiter and Saturn. It's been a wild ride through swirling storms, icy plumes, and methane lakes. We'd like to thank you for joining us on this episode of Cosmos in a Pod. Don't forget to like, comment, share, and subscribe to our channel for more cosmic adventures. And for even more breathtaking visuals and behind-the-scenes insights, check out our YouTube channel. Until next time, keep looking up and keep exploring.